From parallelograms to triangles. So this is our next lesson here. We're going to compare parallelograms to triangles and kind of look at some things which should kind of seem familiar. Our I can statement is I can explain the special relationship between a pair of identical triangles and a parallelogram. So make sure you've got your stuff down, ready to move on. So we're going to look at the same parallelograms and their different bases and how that makes things different, I guess is the best way to say it. So first things first, here on the left, we actually have a copy of the same parallelogram. Okay. Over here on the left, we've got a base and a height. If the base on this is 2 4/10 centimeters and its height is 1 centimeter, what's the area? Yeah, well, we would take 2 4/10 times 1, which would give us 2 4/10 square centimeters. If we look over at this one, we have the height of the parallelogram, this h, is 2 centimeters, knowing that the entire area is 2 4/10 centimeters. How long is this base piece? Well, if this is 2 4/10 square centimeters, this has to be 2 4/10 square centimeters. So that means that if h is 2 centimeters, then what we have to do is we have to take 2 4/10 and divide it by 2. Well, 2 goes into that 2 one time. Hang on a second. Put that down here. Two goes into that 2 one time, which gets us 0 here. 2 goes into that 4 2 times. So that means that our height, or our base in the second one, is 1 2/10, which means that if this is 2 4/10, that our base this way is 1 2/10. The reason why we know that is these are exactly the same thing. So if they have the same area, and I know that the height on this one, looking at it this way, is 2, all I have to do is divide that 2 4/10 that I know to be the area, and that gets me that missing piece. Because remember, we're still talking about, with this, we're talking about a base times a height, or that length times width. Okay, so we looked at how the parallelograms, if they're equal, they can tell us some different things. What about if we use two triangles? Look at all these polygons that are here. What I want you to do is I want you to be able to draw a line to decompose each of these polygons into two identical triangles. Okay, and I'm going to actually have a digital link over here on the side for you guys to use for this. And then which of these can be cut into identical triangles? So if you've used the link, then you should be able to figure out A, you should have been able to cut into identical ones. B, you should have been able to. C, you would not, because you've got some different skewing to the lines. D, you could. E, you're not going to make identical triangles by drawing lines through them to cut them so that they're exactly the same. F, you can, and G, you can. So really, it's only C and E that you can't. So E and C, while they both are quadrilaterals, they can't make identical triangles when you cut them apart. So knowing that, if I use these triangles here in this particular one, Would I be able to make these all into some sort of parallelogram? Any of the pairs? Like, would I be able to put both the P's into one, or both the Q's, or both the R's, both the U's, the T's, the S's? Would those pairs of triangles end up being able to be, or would be able to be used to easily make a parallelogram? Yeah, and you could make other shapes with them too, but it would just be a matter of turning things to make them into parallelograms, right? Like, for example, if I take this one here, and I take that piece, and I rotate it, and put it on, even if I take this edge and match it up with this edge here, forgive my terrible drawing, but it does make a parallelogram, right? Because this side and this side are going exactly the same way, even though my lines aren't perfect. And this line here are parallel, and they're also the same length too, which is what we talked about the other time when we were talking about lengths of parallelograms and how they looked. Okay. All right. So what does that all mean? Well, first we tried to decompose or break apart quadrilaterals into two identical triangles. We found that not all quadrilaterals can make two identical triangles, but parallelograms, we can make identical triangles. We also found that we could put pairs of identical triangles together and make quadrilaterals, and we could also use those same pairs to make parallelograms as well. Okay, so today we were talking about how we can find how pairs of identical triangles are specially equipped to help us find parallelograms and make parallelograms in different ways. Okay, all right, so hope you got everything down that you need and that you're ready for your next part of your lesson. Be sure to like and subscribe.